Hello everyone, so welcome back to my channel. So today we will discuss about a very interesting problem. That's name is find transition point. So this is the problem of the day of 4th November. Okay, so let us discuss about that problem statement. So you have given a sorted array containing zeros and ones only. Okay, so you have given an array and which is containing only zeros and ones. Okay, so find the transition point. Find the transition point, the first index. That the transition point, which was means of that you have to find the first index where one was observed. Okay, and before that only zeros was observed. That means is at those point where we have to be getting where you have to get your first ones in this given array, and the array is in sorted form. Okay, means of that this is your given array 0 0 0 1 1, and so their transition point is 3. Means why? Because of that 1 is present at index 3, so that's why the output is equal to 3. Okay, I hope you have to be understood that problem. So let us discuss about that problem example and then approach to how to solve this. Okay, so here we have to be solve this approach. So how to be solve that? You have given an array and their length is 5, and this is an array into that sorted form. Okay, so how you can solve this problem? So what should be your approach? First of the approach is that you have to be traverse an array till 0 to n. Okay, till 0 to n, which is 0 and less than n. Okay, and each and every time you have to be check that if the current element is 1 or not. If it is 1, so what we will do, we will uh, simply return their index. I hope it should be clear to you that what we have to be doing here. I'm just writing that code that how you can solve it. Return your index. Otherwise, at the end of the loop, after the end of the loop, you would be return minus 1. Means of that you are nothing getting your first one. Okay, so now let us try run this approach. How you can run? Let us see about it. First of all, we will run the loop, which is index 0, index 1, index 2, index 3, and index 4. Okay, first of all, the array of 0 is equal to 1. Array of 0 is equal to 1. No. What we will do? We will simply move again the next element. The next element of again is 0. So again we are moving to the index 2. Again it is 0. So we have to be moving next element, which is 1. So if it is 1, so we will simply return 1. We will simply return their index which is 3. So our output is 3. I hope it should be clear to you. Okay, so our output is 3. Okay, now again uh, that is our next example. Again we have to be checking that first of the index 0 element having 0, so we have to be moving the next element, and the next element is also 0, so we have to be moving the next element, and so on, so on. So in this given array, the nothing that one is getting in this given array, so we will simply return minus 1. I hope it would be clear to you. So this is the approach having a time complexity. So their time complexity is order of n. Their time complexity is order of n. And space complexity, we have to be nothing getting any space. Okay, so there is constant space time, because we have to be taking nothing has to be space at right now. I hope it should be clear to you. So can we optimize it? Can we optimize it? Yes, we can optimize by using that binary search. We have to be searching, perform the searching operation, because this is a linear search and we have to be moving on binary search. I hope it should be clear to you. Okay, so we have to be moving that binary search. How you can solve it? How you can get that binary search for this particular problem? Just like it. Okay, how you can perform? First of all, you should have to be get that two pointer, which is left, right here, and the right pointer should be point here. Okay, so we have to be check that we have to be making some loop, which is while loop, and each and every time we have to be just checking that left is always less than and equal to right. I hope it should be clear to you. Okay, and again and again we have to be checking that what is their midpoint. So we have to be getting their midpoint, which is end of mid, and mid we have to be count that left plus right minus left. Why we have to be getting these types? Because of that we have to be remove their remove their overflow condition. Okay, so again we have checking that left is at right now is 0, and plus right is at right now is 4. So 4 minus 0 is equal to 4, and divide by 2, so this is a 2. So 0 plus 2 is equal to 2. So their half point of this array is 2. So index of 0 is, so index of 2 is this, and this is their midpoint of this array. I hope it would be clear to you. So now we have to be three conditions. Now we have to be two conditions right now here. First of all, if array of mid is equal to 1, I hope it would be clear to you, is equal to 1, or we have to be performing some operation, otherwise it would be 0. If it is not 1, so what it would be, this is this should this would be that would be a 0. So what we will do, we will simply, if it is 0, Suppose of that array of mid is equal to 0. So what we will do? We will simply move their right pointer, uh, move move their right pointer from here to mid minus 1. Mid minus 1 is that at right now here. If it is because of that, sorry for my mistake, we have to be move that left pointer. Why? Because of that, we have to be smaller than at right now here. So we have simply moving our left pointer to mid plus 1, which is L is equal to mid plus 1. I hope it will be clear to you. So we have to be getting our intuition. So left would be simply updated by mid mid plus mid plus 1. I hope this is clear to you that what is our intuition. Okay. Otherwise, if it is 1, suppose of that our mid value is 1. So we have to be two conditions. Either it is our first one, this is our first one, or it would be not our first one. Okay. So how you can check that? If it is 1, so we have to be simply checking that their previous value. Their previous means of that if it is if it is array of mid minus 1 is equal to 1, and why would we getting that n? because of that i'm just I'm just understanding to you, and mid minus 1 is greater than and equal to 0. Okay. So how you can solve it? That mid minus 1, suppose of that I'm just writing some array which is having a all of the number is 1. Okay. So at right now condition, the output would be 0. It is clear to you. Okay. So we have to be checking that mid minus 1 is equal to 1. So mid minus 1 is equal to 1. So again and again we have to be checking if it is equal to 0. If it is equal to 0, so what we will do? We will simply, if it is not equal to 1 and mid minus 1 is equal to 0 is greater than 0. Suppose of that our mid value is here. Our mid value is here, and mid is greater than 1. Mid mid minus 1 is greater than 1. Because of that, mid is representing that index right now here, and mid minus 1 is greater than 1 means of that all those number which is previous number, it would be the maybe have a chance to to get that one. Okay. So again and again we have to be move our right pointer to mid minus 1, to mid minus 1. I hope you have to be getting my point. I'm just repeat myself that what is my intuition. Suppose of that this is our mid value. Okay, so mid value is 1 and mid minus 1 is also 1 and mid minus 1 is also okay. So what we will do, we will simply, this is our right pointer, so again and again we have to be moving our right pointer to from here to mid minus 1, which is here. This is our right pointer and this is our left pointer. I hope it will be clear to you. When our right pointer, when our right pointer move to here to till here, that left and right pointer, left pointer is representing index 0 element and right pointer is also representing the 0th element. So at that time right pointer would not be moved to before that element because they have to be nothing element at right now. Okay, so we have to be simply return those index, return those index. So that's why when the index value is greater than or equal to 0, so we have to be simply moving our right pointer to mid minus 1. Otherwise what we will do, we will simply else return return mid value. I hope it would be clear to you. It would be clear to you. Because of that, suppose of that left and right pointer is representing the 0 and 0 plus 0 is equal to 0 and their mid value is equal to 0. So our mid value is equal to 0. So that's why we have to be simply return our mid value. So mid of 0 is equal to 1 and this is our index value. I hope it would be clear to you. Okay, if it is, while loop would be end here. Okay, and now we have to be checking that, check that if it is nothing the element would be found. Okay, so our binary search would be end and we will simply return minus 1. So their time complexity is order of, when we have to discuss about the time complexity, so their time complexity of order of log n. Okay, order of log n. And their space complexity is order of order of 1. I hope it will be clear to you. So that's why this approach is very optimized than compared to the earlier approach. Okay, now we have to be moving on our coding implementation of this approach. So this is our left pointer which is indicating the zeroth value and this is our right pointer. Okay, we have to be traversing the loop which is have to be performing a binary search. Okay, after that binary search we have to be simply return our mid value. Okay, and otherwise if it is not found so we will simply return minus 1. Okay, so we'll just compile here. This is our C++ solution. Okay, and we have to do nothing. Will we do, we will be copy and paste into that Java. I hope it will be clear to you that what is our intuition, so you can solve at any of the time. This is comment section part, and I hope it will be clear to you that what we have to be doing. Yeah, so if you have any doubt, so please comment on my channel, please like my video, please subscribe my channel. Thank you.